The point of this is to help develop this technology. We really need to accelerate the rate at which we understand how this process works in different soils, different climates, different crops. And then once we understand that, deploy it where it works. The opportunity to do a citizen science approach, have folks do this in their own lawns in a way that it's still controlled, monitored, but in new environments quickly would be awesome. There are barriers and things we need to figure out, but they're definitely within the realm of possibility. And to your point, with something like OpenAir, where we can crowdsource things, when we can bring the right people together with a network of people who are passionate and knowledgeable about this, that's how we can make it happen. So I'm excited. From a scientific perspective, again, what we really need to better understand is how do different soils and climates and crops impact this. And so we've got over 100 acres in California, but in terms of the climate and the soil type across those 100 acres, we don't have a whole lot of variability. Now we've got another really good in member by doing that here in New York, but to fill out all the space in between is something that we need as fast as possible. And that's something where, yeah, if we've got 500 people, the variability in soil type, precipitation, temperature, even type of grass, the root depth, all of these things can really help accelerate the science. And what we're pretty passionate about with our research group here is accelerating the science to a point where all of this really expensive and time-consuming monitoring becomes less and less important as our understanding of the process increases, right? So once we have a pretty good understanding of saying, okay, the pH of this soil is 6.5, it's got this much organic matter and this much clay particles, so we can expect a general range of bicarbonate production with a certain type of mineral. Okay, so now when a farmer wants to do that over 100 or 1,000 acres, rather than needing 100 or 1,000 or 5,000 lysimeters to make sure that they're capturing the spatial variability, they could maybe put out 1 or 5. That's just making sure that we're within that range. And that's really important for that farmer getting credits and payments for their practices and making sure that it's getting the type of carbon sequestration we want. So that the value of this, it would be incredible. There are a wide range of estimates for carbon sequestration potential per acre with different mineral types, different soil, so rock dust composition, soil type, soil conditions. And so the idea is that we're testing, does the process work in all soils or in that particular soil? With this particular application process, all of these things, it's really exploration of how does the process work. But what makes enhanced weathering different from a lot of soil carbon sequestration is we're not talking about organic carbon. And even though it's the reactions are occurring in the soil, the sink of carbon is water, which is dynamic. It doesn't just hang around in the soil. And so for a lot of soil carbon sequestration monitoring strategies, you might take a soil sample once or twice or 3 or 4 times a year, and you can measure the organic carbon and send it off to a lab, and it's a relatively inexpensive process. Unfortunately, for something like enhanced weathering, if you just measure the soil once or twice a year, you're going to be missing a lot of the carbon that you're sequestering because it's in water and it's constantly moving. And so it's not difficult to do. So it's something that we could easily put into a protocol for a citizen science approach, but it's not as straightforward or as cheap as collecting a soil sample once or twice a year and sending it off. What we have developed and optimized is the use of a specific soil water sampling device that has to be installed in the soil. So this is called a lysimeter. It's a 12-inch PVC tube, a porous ceramic cap at the base. At the top, it's got a sealed rubber cap that you can remove easily, and then a tube here. And so what we do is we install this in the soil. You remove these rings. We have a vacuum pump. The vacuum pump is probably the most expensive part of this. They run, the ones that we use run about $200, although I'm sure we could find something that's cheaper. Set vacuum here at about -40 kilopascals. Close it off, add back on the ring so it holds vacuum. And then you wait a few days. And hopefully in those few days it rains. And once this is in vacuum, water from the soil will slowly percolate into this permeable membrane without getting a bunch of soil particles or even bacteria that might change the carbon chemistry. And then we come in a few days later with a syringe and can take the water from the top here. So this stays in the soil the whole growing season. If the soil doesn't freeze, it could stay in year round. So these cost about a little over $100 a piece. They come in different lengths. And so for some lawns, a 6-inch might be plenty, but those will still run 80 to $100. So yeah, if we could come up with a way to make this a DIY system that is even more affordable, that would be amazing. Again, most of this is just PVC. So it's really this part at the end, this porous ceramic bit that needs to be just permeable enough for soil water, which is its own science. It's its own field of science of how soil water works, but it's not just free flowing. And so that's why we've got to set a vacuum and really force it to move into the space. If I had one of these in my lawn, I'm already there. If I've got a relatively inexpensive pump, that actually makes it a much more feasible process. Yeah, if we could crowdsource solutions to that, that would overcome a huge barrier. I'll start off by saying, in order to do this right, what we would want is really at least 2 lysimeters, one where we're applying rock dust, and one in the same lawn in an area where we're not applying rock dust. Because that's the other thing, is we want to be able to compare those throughout the season, throughout the year, all these different changes. Yeah. So we want to make sure that the rock dust is driving what we're seeing and not just natural variability. We're taking measurements ideally every week. That changes depending on how much water you have. This process just needs water. So when we have dry weeks, we don't get samples. Our group out in California only gets samples if it's actively raining or if it's just been actively raining, because they're so water deprived. So yeah, once you start applying the rock dust, it starts to dissolve. You would see an increase in weathering production once you've applied the rock dust. And then if we can figure out a system where folks can send it to a lab to do this relatively quickly, that would overcome a big barrier too, which is why this type of rapidly scaled up while still closely monitored approach in a citizen science project would be so important, so we can really better understand it. There are a number of different ways to get it. So to your point, if you're near one of the mines that has existing stockpiles of this rock dust, that would be great. We partner with a number of different mines around the country, and so we could help facilitate some of that. We also partner with some folks who it is their job to help farmers find local rock dust supplies, and so maybe they could be resources here. And there are also studies and databases available to tap into. So we could come up with or create a relatively streamlined system that could get folks, regardless of where they are, the information to know who they could call to get the rock dust. And then there are also companies that are selling these products. So we're actually doing some product testing with one company, and their products are already commercially available as a plant fertilizer. We're testing its capacity to draw this or to drive this enhanced weathering process. You don't need a whole lot of space. You could have your whole lawn and have a few lysimeters out there, and that's your control. And then one 4 foot by 4 foot box, or one 4 foot by 2 foot strip, that is where you're applying rock dust. And so if folks say, hey, this sounds really cool, but I'm not trying to risk the health of my beautiful managed lawn if this goes wrong, they could pick one portion of it. You don't need to do this on a very large area. In our field trials, we're applying a number of different amounts, but what we generally say is 20 tons per acre. For someone who has a 1 acre lawn, that's a pretty big lawn for most US households, but there it probably wouldn't be feasible to spread rock dust all over the thing, which again, we want some part that's controlled. And so the rock dust spread area, we imagine if you get a 50-pound bag of wollastonite from that company, you would spread that on an area to reach that 20 ton per acre equivalent. Right. And that would be the study area. And I've done citizen science projects where there's an app called SitSci. That's, I think, the easy part is the data stream and the information flow. Yeah, which again just makes this kind of idea even more feasible. It would require another step of detailed, data collection to try and do that. But even on a lawn scale, if you've got a clearly delineated plot where you've got your rock dust and then everywhere else, it could be something as simple as on the SitSci app platform, before you mow your lawn each time, take a picture that shows, the untreated grass with the rock dust treated grass next to it. And that alone could go a long way in being able to say, it's greener, it's taller. Of course, if we could go a step further, and before every time you mow the lawn, you bring out a ruler and say, okay, the grass is, you make 5 measurements where you've put rock dust. Okay, the grass is 3 inches. You make 5 measurements where you didn't, grass is also 3 inches. Okay, no significant difference, or maybe there is. Something like that itself could be a pretty inexpensive way to assess that. And yeah, that's certainly something we would want to add to that if possible. I've kind of envisioned there can be a little yard sign, even something like that, a sign that says this is part of a national research network helping to understand carbon dioxide removal. So maybe they're not getting the data in real time. That's not a realistic expectation. But I think every 6 months, annual, something like that, where at the end of the grow season, you get an email that says, here's the results as a spreadsheet. That's something that I think is a bit more realistic given the amount of time it takes to go through the data. Still keeps people engaged. And again, they're able to kind of know that the actions that they're doing are improving our understanding.